Latency, visualizing serverless performance in 3D. Our speaker, Renaldi Gondosubroto, is the director of Cloudetica Solutions. He is also an AWS subject matter expert and hosts all 14 AWS certifications. In this talk, he will show you how to visualize serverless latency beyond line chart and uncover the real shape of your system performance. Please welcome Renaldi.
Thank you, Kathy. So, hello everyone, 大家好, since we are in Hong Kong after all. I'm Renaldi, pretty much from Melbourne, Australia. And yeah, pretty much just wanted to give a bit of talk about shape of latency, more or less talking a bit about how you are able to visualize trends and essentially a bit more of the performance for your serverless workloads, essentially within 3D to be able to get more visualizations and understand a bit more about the trends that really underlie it. So yeah, without further ado, we'll get into it. So a bit about myself, as introduced by Kathy, I currently hold all 40 certifications from AWS. Also, I'm an author instructor, including using Amazon Bedrock, published by Wiley. I'd like to pretty much add a bit more incentive to get a bit more interactive this time around. So at the end, I'll hold actually a bit of a question and answer session. And those who essentially ask questions, I'll also give a copy of like my latest book, which is basically using Amazon Bedrock too as well. I have 3 copies to give out, so yeah, feel free to keep in mind as well very much any questions you have as you go along, and yeah, pretty much more than happy to give out some. And yeah, pretty much also host a podcast as well called Serverless Sorcery, spoken internationally as well at over 50 events and conferences, and yeah, pretty much also organized the Melbourne Python meetup. And yeah, in general, passionate about AWS, open source, generative AI, VR, so yeah, a lot of things. And agenda more or less looks like this. So a bit of a inspiration first about talking about why P95 isn't enough, essentially, within talking about troubleshooting specific like workloads, talking about creating a bit of an experiment design to be able to understand a bit more of how to be able to start crafting a bit of a thought experiment for being able to solve this particular issue. Then talking a bit more of the architecture, like what the architecture would look like in terms of this workflow and how to be able to understand it a bit more, how to code it up, how to understand the code and practice, and finally talking about the extensions that can be done towards this, and also about understanding a bit more about how it really can be further developed to be able to uncover more potential trends and in general be more user-friendly. So why isn't P95 enough normally for trends? Well, usually averages hide structure. Sometimes there are certain trends that we won't be able to see just from looking at normal P95s when you look at certain metrics, certain troubleshooting. And that's why we need to be able to go beyond that and be able to understand more trends beyond the P95. And the fact that they can look stable oftentimes is another key metric of why sometimes it might not be sufficient. We need to be able to go beyond that and be able to also see other metrics, see other potential trends that can help us look deeper into what might the underlying cause be and potentially any other potential issues that might be present as well. And of course, spikes can emerge as well under specific conditions. There are very certain spikes that you would need to look at different trends on, whether it be P95, whether it be P99, or other kinds of metric latencies that, or visualizations that you need to be able to look at before being able to see such patterns, essentially. So let's look at latency as a landscape as well as part of this. The goal really is to be able to see when and why, not just how much. So as part of that, we would have access in terms of time, concurrency, and latency, because we want to be able to understand from these particular axes how we're able to visualize these trends and then be able to better understand how to essentially best put them forward, to be able to identify new trends. And as part of the surfaces as well, we will also be looking at different ridges, craters, valleys, and I'll also be giving a bit of an illustration of what that would look like as well. So for the experiment design itself, what really needs to be done is to be able to get somewhat synthetic but also realistic traffic patterns. To be able to essentially visualize these kinds of patterns and be able to put them into practice, to be able to have them best shown of how it would best be visualized in terms of how it would peak, how certain trends would emerge, and that's why we're looking at these kinds of different axes and also different kinds of patterns essentially as part of that. It also would be comprised as well of a mix of warm and cold invocations particularly. We need a bit of more of a regional variance as well in terms of multi-AZ spread too, to be able to understand how it would perform under different availabilities as well. And of course, have a bit of a record as well. So considering things like duration, init, duration, memory, retries. So these kinds of things need to be put into practice and pretty much need to be put in consideration to be able to understand as part of the experimentation that is designed itself. So for the AWS building blocks itself, there's a few key components that we'll be covering here. So the API gateway, start off with pretty much to Lambda, and usually it's pretty much like a Python node kind of framework. Lambda to the DynamoDB, where we pretty much will be using a tenant shared table, X-ray tracing enabled end-to-end, and finally, also being able to utilize CloudWatch logs as part of the backup signals. So let's get a bit more into the code now. So I'm going to talk about a few code snippets just to pretty much give a bit more idea about how it would look in practice, how it's essentially coded up, and to be able to understand a bit more as well of how we are essentially going to be able to be logging certain things, be able to keep track of things, and put through some certain metrics. So first of all, talking about the Lambda itself as a cold start flag, essentially. So essentially in this part of code, this shows a bit more about how it's put in practice, especially as part of the cold start flag. So yeah, particularly from the X-Ray SDK, we pretty much are just importing in the X-Ray recorder, patch all, and then pretty much create a handler, which essentially just accordingly sets the cold start flag, sets the time, pretty much like sets the recorder accordingly to put these specific annotations for the cold start, memory, and keep track as well of the duration and essentially return the relevant metrics as part of that. Turn on tracing itself. So we need to be able to enable X-Ray itself on the specific stage that we need as part of the API gateway. We need a Lambda as well to have the active tracing as active itself. And we need to also have the DynamoDB SDK calls to be auto-captured with the X-Ray SDK. So this is the architecture. And I do apologize if it's a bit small, essentially, but it is more or less meant to give like a high-level overview of what this kind of architecture can really look like within a production environment when it's set up. So I'd like to just walk through a few key things, basically. Start off with, at the very end, pretty much we have the users basically loading a specific generator that pretty much sends an HTTP request. And over at the end, when we essentially get into a specific region, we pretty much have the API gateway, which it goes through. Then pretty much we have the Lambda function app, which we talked about earlier. And that essentially would be able to help us do a few things, which is basically start off with having the specific read write towards the DynamoDB. It would also pretty much have us emit the specific traces as well towards X-Ray, and also pretty much be captured as well through the CloudWatch logs for any debugging necessary. And as part of that as well, it would also help in terms of having optional schedules, in terms of having, for instance, event bridge schedule warmers as well, to be able to essentially help to continually keep the Lambda warm essentially for continuous invocations. And yeah, pretty much also potentially have batch exports as well. And that pretty much would then have the X-Ray essentially send through the get trace summaries as part of that, which would then send through the specific traces as well. Could be pulled by a Lambda or step functions appropriately. And that would pretty much then feed into the specific data lake, which in which case could be contained by S3 bucket essentially, and accordingly flatten transform with glue or Lambda, flatten the rows, and pretty much have it sent through S3 bucket for latency flat, and pretty much just accordingly send it through to Athena, Athena external table as well, where so certain like CTAs or views will be captured, then sent into the analytics and visualization aspect, where, as you can see over there, we're basically capturing the aggregated views, and that is then sent into QuickSight accordingly. And of course, errors and metrics pretty much can be captured as well through the original Lambda function where it was sent through as well, and that pretty much would then all from QuickSight be visualized. We can pretty much have certain heat maps, capture that in terms of like the time and concurrency, send that through a latency landscapes dashboard, and pretty much from there, we can pretty much make certain decisions through being able to best look at the certain operation decisions. So pretty much look at certain things, such as if we, for instance, like need to have like better like targeted provision concurrency over there, or pretty much have certain retry policy changes, or have like specific like tenant partitioning. So that's just more or less like a brief run through of more or less like how it would look like from an overall perspective. So to build onto that, as part of that, we can also export the traces to then S3. So specifying some things, including like the end start, and pretty much, of course, getting the specific like trace summaries as well from X-Ray. And from there, we pretty much would capture things like aspects such as like the ID and the docs itself as part of the grid traces. And pretty much from there, we would then look at getting essentially using gzip particularly to be able to appropriately write the specific like segments of the documentation as well. And pretty much from there, get the relevant key, put the specific object within S3, and yeah, pretty much essentially accordingly print the appropriate key. And as you recall as well earlier too, we did talk a bit about flattening the to analysis shape itself. So what we want to do as part of this, we want to keep only the specific like fields that are necessary. We want to keep it like one row per invocation, and really keep the specific fields, including like what region is, function is, cold start. So yeah, these are key things to pretty much like keep track of. And pretty much doing a bit of simple ETL as well as part of the Lambda glue job, as mentioned. I just want to highlight this as well, as it's another key aspect of how it pretty much it's performing the specific like ETL. So yeah, pretty much in this case, just creating a 2 rows function as part of that, getting segmentation, loading the segmentation, and pretty much just getting the specific metrics as well. And pretty much from that, getting yield and pretty much just specifying the timestamp, getting the duration, region, function, cold start, init duration, and yeah, pretty much just accordingly returning status. And as part of that, for the Athena table itself, when it then goes to that stage, we want to be able to create the specific external table, which, as mentioned before, was the next step as part of that. So creating the external table itself, it doesn't exist, latency flat, specifying, of course, like the specific key metrics as well, like the duration, region, as mentioned before, and yeah, pretty much accordingly just writing it that way. And identifying the specific ridges, specifying in terms of essentially what's burst intensive, and yeah, pretty much just specifying it as the select. Selecting is basically the specific metrics that we want, aggregating it appropriately, and yeah, pretty much just essentially putting a specifier on what specifically we want to be able to find. In this case, P95 essentially. And we also can then look for specific cold start craters as well, in which we would then select essentially the function, what would be the cold starts itself, and what would be pretty much like P95 as well, aggregate that appropriately, and pretty much then have that ordered accordingly. And yeah, pretty much that would pretty much show a bit more of the cold start craters. And we would then move on to visualization in terms of the heat map itself. So we would have accordingly the data sets and the heat maps itself. Pretty much we would have the aggregated Athena table as the data set. We would have the specific like heat maps, the visualizations, and these are just sample ones, mind you. So these are just sample ones that can be visualized, and in that case, for instance, I'm just visualizing for the first one, the t-minute, and pretty much the function or specific like region. Accordingly, pretty much for the second visualization, I could also be showing the time in minutes against the bin invocations per minute, essentially. And accordingly, that would pretty much be revealing ridges, whereas the previous one pretty much would be just showing the average time, essentially. And we can then look at reading a specific landscape. So accordingly, from reading that specific landscape, we would be able to have specific ridges being shown in terms of short, which would mean that the short burst essentially shows the P95 spikes. Craters itself would represent cold starts that are visible as init valleys or spikes. As part of that, we would have the valleys itself, which would essentially show a retry of smoothing apparent performance. There are cross sections as well that could be seen that pretty much would be also comparable as well when we see regions side by side. And we could also build on that as well by, of course, asking Bedrock particularly to summarize heat map changes. And I'm going to go into a specific segment as well later too, which I'll talk a bit about the potential of NLP as well for this. But really, it's all about being able to make it more user-friendly and make it more possible for users to be able to query data easier. And as part of the provision concurrency strategy, as part of this, essentially, it's really specifying the function alias, essentially, specifying the type alias accordingly, and just more or less just putting through the properties as well accordingly. And for the DynamoDB itself, since it's a multi-tenant, particularly for this particular deployment, we want to make it essentially in terms of the adaptive capacity. We want to be able to specify the specific shared table to be essentially based on the tenant hotspots. We want to be able to have the adaptive capacity, rebalance the partitions accordingly, and pretty much just have the heat map accordingly with the tenant times time, and pretty much colored by RCU and WCU throttles, and yeah, pretty much have action based on that, and pretty much just have and the action for that could be the per tenant GSI or table split, essentially, if persistent. So from a workload of a checklist, it would look like something like we need to enable tracing first from the API gateway perspective. We need to be able to have the export tracing logs to S3 in terms of a batch job, flatten to per invocation rows accordingly, and pretty much have then Athena create the table accordingly, aggregate the features, QuickSight, then build the specific heat maps and compare specific slices. We would then need to have the iteration to be done, in which we need to be able to change the config to reread the specific surfaces. And potentially, we could also integrate with agents as well, in terms of when integrating with an agent group to be able to run Athena CTSAs and pretty much fetch the latest integration accordingly. And of course, as part of this, we need to also set specific guardrails. So guardrails essentially is set in terms of, okay, what do we need to put so that it doesn't go off of what we expect and also off of our cost expectations. So considering things like sampling rate versus cost, PIA and traces, for instance, how can we avoid sensitive fields that we are looking for while we are going through specific traces? So this is all very important to, especially from a compliance perspective, to ensure that we are not going, over the rails. And we need to be able to keep the ND-JSON stable as well, have this document schema accordingly stable too. We need to be able to tag specific runs as well with config metadata. And if Bedrock particularly is being used, or generative AI particularly tools or is being used, look at setting up accordingly Bedrock guardrail essentially for regulating specific topics as well when we actually do try to query the specific models as well, basically as part of this, to be able to return the appropriate analysis based on what has been returned essentially from the visualizations. So as part of a quick demo, I'll be just showing a bit about a custom dashboard that more or less was created based on this kind of deployment. So as you can see, the first visualization is just a bit of a heat map, which just shows timestamp concurrency. Yeah, pretty much so. Just basically showing a bit about how it would be looking like, at least. You can notice the peaks and troughs essentially that are seen over here, basically the peaks being shown by the red spots, and yeah, pretty much the troughs are by the white spots. So yeah, it just shows a bit more about the visualization in that. And of course, we could look at that in terms of a 3D surface landscape as well. You can see how we have the time, concurrency, and latency axes over here as well. And pretty much that would be showing essentially the 3D model. That's essentially just an alternate representation of that. And yeah, just shows more or less a bit of a visualization of that. Minute bins itself, as we mentioned before, could be another visualization. And in this case scenario, it's pretty much just visualizing the average versus the P95. And yeah, we can pretty much just see a bit more about how it would be represented here accordingly, how we would be able to keep track of essentially what is what. And yeah, finally, and yeah, this pretty much helps with comparing both essentially to be able to see if the trends do match or if there are anything we might have missed. And accordingly, from tenant throttling itself, we would be able to then see the different groups as well of tenants as well. And in this case, I'm just naming a tenant A, tenant B, tenant C, basically. So that pretty much would show it. And of course, we could also simulate as well in terms of provision concurrency, how that would affect certain visualizations accordingly based on historical data. So you can see basically how it could potentially affect it and basically make decisions based off of that. So this really helps as a decision operation tool, essentially, as part of this visualization. So yeah, that pretty much is just a bit of a showcase based on that and just the potential of it, more or less. So as part of the extensions, there are potential additional cost time contours that can be added in terms of like Lambda, in terms of gigabytes per second. We could also potentially include like the queue depth, add cold start warmers as well, particularly as part of this. Have like specific like region AZ overlays as well as part of this too, like add more comparisons, more cross-sectional possibilities to be able to compare the performance from one region to another. Automate weekly reports as well to be able to essentially have weekly reports come in with specific visualizations to be able to, well, for debugging or for other purposes as well, essentially. And even building on as well for allowing for natural language queries as well. QuickSight particularly is one of the tools that's really great for this, since the QuickSight Q suite essentially was able to pretty much, you can query it and pretty much you can query like the specific like visualizations that are already on QuickSight, but essentially building onto this and being able to integrate into the website as well and pretty much just being able to query these kinds of 3D visualizations would really help as well in identifying some things, especially for, I would say, like the more non-technical folks, essentially, sometimes to be able to get to the bottom of things more quickly as well. So yeah, pretty much, just to pretty much like put up my book as well, as I mentioned before, if you're interested pretty much in more of the generative AI side as well, of building onto things, pretty much, yeah, have like my book as well recently out as well, like using Amazon Bedrock. Yeah, pretty much. So yeah, pretty much just wanted to just briefly mention that as well, which you can also already like find online now as well. So yeah, some takeaways. Performance is a shape, not a point. Heat maps really surface when and why spikes happen. 3D visualizations help to be able to get these patterns more and be able, yeah, you'd be able to get more targeted changes to be able to beat blanket tuning, essentially. So that is all from me. I specifically reserved a few minutes for questions. Yeah, are there any questions currently? Yep. Yep.
So adding more log trace that may impact that may make the response slower, that may affect the performance, but that not really not much. So how to support that?
I would say that it's really dependent on a balance. Like, I wouldn't say adding logs necessarily slow down performance. I think like normally, like if you do some overlogging, like it might essentially, but normally I would say like it doesn't really affect performance. But even if it does, you would essentially need to, I feel like, look back into root cause of that, because there's a number of possibilities, but normally I don't think it would affect it that much. Essentially, you would basically just need to look at essentially like what the root cause is first, and pretty much like look for that. But even if it does stem from that, then pretty much there would be a balance of like how many metrics you particularly log, and what kind of metrics you're logging, like the traffic of that. So yeah, that's it for me.
So you mean on AWS, the cloud architecture actually, your solution is causing more of the cost, but not affect much for performance, because we all solve the cloud structure that may use asynchronous like that.
Yeah, it's more focused, I would say, really for a troubleshooting perspective. It doesn't really cover too much on kind of like the performance perspective, because pretty much it assumes that you're working with essentially what metrics you already have. So it's not covering too much on that, but I think it's a different topic pretty much when it comes to like which log specifically would like degrade your performance and such, basically. Yep.
So with such a lot of 10 metrics and samples, how would you suggest the operation to maybe throttle or take a sample of those metrics or samples? Because when the application grows really large, there will be a lot of sample and metrics and loss that is coming into the system. And such process can cost a lot to the full operation. So how would you suggest to maybe control costs on the telemetry and analysis of the performance? Thank you.
I'll give a really short answer because I see that the time is up. But I will give you a longer answer after this. But short answer is there's a number of different ways, I think. I think Lambda, pretty much on the Lambda side as well, like throttling itself is definitely one of them. And of course, like optimization of the metric itself, I feel like it's definitely like one of them in terms of finding out like which metrics would really be effective for this, and pretty much considering based on that. But that's the short answer. I'll answer further later. But thank you for now. And to both of you, I'll pretty much give you the copy of the book. I have one more copy to give out. So if someone grabs me later and just asks me a question and just mention you want the book, I'll give you the book. So thank you.